All right, let's look at the questions from checkpoint 8. So got a couple different functions here. So this first one, I want to, do some analysis here. So of this function, let's just take it piece by piece. First thing, find the intervals where the function's increasing and decreasing. So what is it that tells me where a function is increasing and decreasing? That comes directly from the first derivative. So let's do that. F prime of x is going to be equal to, using the power rule, 4x cubed minus 4x. So rather than finding increase and decrease, let's do this. Let's find the critical points. So I'm going to set the derivative equal to 0. From there, I think I can factor out a 4x. So 4x times x squared minus 1 equals 0. That factors a little deeper. 4x times x plus 1 times x minus 1 equals 0. So from here, I get 3 critical points. X equals -1, 0, and 1. So those are my critical points. So this will help me figure out what's happening basically everywhere. So I'm going to make a chart. So basically, I'm going to split up all the real numbers along these divisions. So x is equal to -1. Don't be shy, Pin. Is it delayed or is it just not working? What do you think? It was delayed. Okay. Let's clean that up. So x equals -1, x equals 0, x equals 1. And I want to see what the derivative is doing around these points. So I'm going to let's find some test points. Let's do -2. Let's do -1/2. Let's do +1/2. And let's do 2. So I'm going to do the first derivative test. Second derivative test works just as well, but let's try the first derivative test. So I know that at -1, 0, and 1, my function is neither increasing or decreasing. So what's happening at f prime of -2? F prime of -2 is equal to, I'm going to use the factored version. I think it'll be, actually, that probably shouldn't matter. 4 times -2 cubed minus 4 times -2. So -2 cubed is -8. So -32 plus 8 is -24. I care less about the fact that it's -24 and much more about the fact that it's negative. That's really what I'm looking for. So that tells me I have a decrease to the left of -1. So now what's happening at -1/2? So 4 times -1/2 cubed minus 4 times -1/2. 4 times, so -1/2 cubed is -1/8 times 4 is -1/2 plus 2. That's going to be a positive number, so I have an increase there. What about f prime of 1/2? That's equal to 4 times 1/2 cubed minus 4 times 1/2. So this will be exactly the opposite. 1/2 minus 2. That's a negative number. So I have a decrease. And I suspect strongly that if I plug in 2, I will get an increase, but let's make sure. F prime of 2 is equal to 4 times 2 cubed minus 4 times 2. That'll be 32 minus 8, which is 24. And yeah, so this kind of looks like you may have suspected. Just all my critical points are some kind of extrema. So really, I can answer part A now. So where does this increase? It increases on, let's do interval notation here. It's increasing from -1 to 0, as well as 2 to infinity. Is that all? Yeah, -1 to 0. Okay. And it's decreasing on -infinity to -2. And I'm going to join that. I'm going to union that with 0 to 1. So those are where it's increasing and decreasing. I'm going to skip ahead to part C. So locations of any local extrema, because I can get those directly from the first derivative test. I already feel pretty good that all my critical points are local extreme. So I have a local min at -1, local max at 0, local min at +1. So let's go out of order here. And let's find the y coordinates of these points. F of -1 is equal to -1 to the 4th minus 2 times -1 squared plus 11. So 1 minus 2, -1 plus 11, that's 10. So I have -1, 10, and that is a what? Local min. Then also at f of 0, it'll be much easier for me to find. F of 0 is equal to 11. So 0, 11 is a local max. And finally, f of 1 is equal to 1 to the 4th minus 2 times 1 squared plus 11. I think that should also be 10. 1 minus 2 plus 11. So at 110, I have another local min. All right, good. So that's part A and part C. I think I should probably get a clean slate here if I'm going to continue. You're probably wondering if there's a better way to do this. I'm also wondering that. Yeah, let's work smarter in this. So let's close this out. Let's open this back up. Okay, so we did A and C. Check those off. All right, so where's the function concave up and concave down? So what tells us about concavity? That comes from the second derivative. So let's reload the first derivative. 4x cubed minus 4x. And then we'll take another derivative. So f double prime of x is equal to 12x squared minus 4. So I'm going to kind of handle B and D together here, because those both are answered by the second derivative. So first I'm going to look for inflection points. So I'm going to set 12x squared minus 4 equal to 0. So 12x squared is equal to 4. That means that x squared is equal to a third. So my x values are x equals -1 over radical 3 and 1 over radical 3. So I'm going to do the same kind of chart. -1 over radical 3, 1 over radical 3. But instead of testing the first derivative, I'm going to test the second derivative now to get concavities. So I know that at these 2 points, the first derivative is 0. What are some good test points to use for everything else? -1 over radical 3 is about -0.6 or so. So I'm going to use -1, 0, and 1. So what is f double prime of -1? That'll be 12 times -1 squared minus 4. That's a positive number. So concave up at that place. f double prime of 0 is equal to should be -4, right? That's the negative number, so I got concave down. So confirmed one inflection point because I went from concave up to concave down. Now what's f double prime of 1? F double prime of 1 is 12 times 1 squared minus 4. That's also equal to 8. So confirmed a second inflection point. So I know I have inflection points at where? At -1 over radical 3, whatever the y value is, and 1 over radical 3, whatever that y value is. So let's go ahead and find those. What is f? Here's something I'm gonna do to save a little bit of time. These are gonna be the same because hopefully I can convince you of this. These are the same, up to the negative sign, right? So -1 over radical 3, 1 over radical 3. If I raise those both to even powers, they're both going to become positive and they're both going to be the same thing. So because of that, I'm just going to do one of these. So 1 over radical 3 to the 4th minus 2 times 1 over radical 3 squared plus 11. Radical 3 squared is 3, which means squaring that again will give me 9. So 1 over 9 minus 2 times a third plus 11. Let's find that common denominator. 1/9 minus 2/3, which is 6/9 plus 99/9. That's equal to 100 minus 6, 94 over 9. So here are my inflection points, 94 over 9. So something a little bit more than 10. So I got my inflection points. Where am I going to find my, intervals of concave up and concave down. So it's concave down on where? In between the inflection points. So on the interval -1 over radical 3 to +1 over radical 3. And it's concave up on basically everything outside of that. So -infinity up to -1 over radical 3, union with 1 over radical 3 up to infinity. All right. So that handles B and D. The last thing we have is locations of any absolute extrema. So we're going to do the clumsy drop out of this thing again. Open with the stunningly useful Microsoft Edge. All right, where are the absolute extrema? So let's try to find those. And notice I have not given you an interval for this. I'm looking at the function over all the real numbers. So the absolute extrema, I'm going to go back to the first derivative test because that is going to tell me where these things might be. I don't have any endpoints to look at. So the only place the absolute extrema could be is at the local min and local max. But one thing I want to remind you of here, and I'm just going to kind of recreate this. I said that the critical points were at -1, 0, and 1. I also know that this function does something like this. It decreases, flattens out, increases, flattens out, decreases, flattens out, and then increases. So let's talk about absolute maximum first. If I look out way far to the left, my function is decreasing, which means it can go as high. Basically, it'll go as high as you can think of. Think of your favorite giant number. This function will get greater than it. And the same thing is going on to the right, because after 1, this function is increasing forever. So there is going to be no absolute max. But is there going to be absolute min? So this function has a local min, goes up to a local max, goes down to a local min, and increases. There is no part of this function that kind of decreases without like any kind of bounding. So there is going to be an absolute max or absolute min, at wherever our local min, basically at wherever the smaller of our two local mins, and I think they were the same. I said earlier in the video where they were, but I think they were both at a y value of 10. So, and I from this first river chart, it probably happened at negative 110 and 110. And the reason I have two absolute min is because they hit the same y value. So a lot of stuff to chew on there for question one. I'm going to go ahead and move on to question 3 here. Let's look at this one graphically. So now I'm giving you a graph of a function, and let's kind of do some, just use that graph to answer these questions here. So this graph below shows the profits of Worldwide Global International between the years of 2020 and 2035. So our reference year is 2020. T equals 0 gives me the year of 2020. So approximately when were this company's profits rising the most rapidly? So what's going to tell me that? So this function is called P. What is going to tell us, rises and falls? So A and B are about what's happening, where this thing is rising and falling, most significantly. So what tells us about the rise and fall of a function? We can also think about that in the language of increase and decrease. For part A, I want to know this. Where is P prime greatest? Basically, that increase is going to show us, when their profits are growing at the most significant rate. And in this case, I believe that's happening maybe at the very end here. Like it looks like it starts to get linear here, but this is a pretty significant increase. So I'm going to guess, and by the way, all you can do is estimate here, but as long as you're justifying yourself, I'm happy. But I think I would say maybe 2034, because I believe if I were to compare the tangent lines at all my points here, basically the first derivative I think is going to be greatest in that neighborhood. What about question B? So when are they falling the most rapidly? So where is P prime the least? So where do I think that's happening? Well, it's probably not going to be happening anywhere where I have positive slopes. So where is the slope most negative? I think that's around, and let's start eliminating other things. I definitely don't want to choose where it's increasing. So I can take out anything to the left of this point, anything to the right of this point. But I also don't think it's going to be anywhere where the slope is like very shallow. So I think it's going to be something like right in the middle. So let's say, I don't know, I'm going to say 20, what is this? 2026. So why am I saying that year? It's because I think at T equals 6, that is where I'm going to get the least value of P prime. That's where I'm going to get the most negative slope of a tangent line there. All right, part C, approximate when do profits go from rising to falling? So let's try to answer this, or try to set it up in terms of, calculus things that we've been learning. Basically, where does P prime go from positive values to negative values? What do I call that? Actually, no, that's not true. Take it back. So approximately when do profits go from falling to rising? So I think what I'm going to be looking at there is, when does P prime go from not positive to negative, or sorry, not negative to positive, but from decreasing to increasing. So what does it mean for P prime to go from decreasing to increasing? Well, that's equivalent to this. Where does P double prime go from negative to positive? So in putting this in the language of calculus, we're looking for an inflection point. So where does our function look like it goes from concave down to concave up? For me, I think that's also happening at 2026. Because I think if I were to, think about this in terms of tangent lines again, I think everywhere up to this point, my tangent lines would be going from, so I think to the left of this point, the tangent lines, if I go from left to right, are decreasing. The slopes of the tangent lines are decreasing. And to the right of this point, the tangent lines are going from, they're starting to increase. So I think at this point, that's when, I'm going to change the language in this question slightly, but I think that's where the company started to turn around its profits. All right, so that's all for checkpoint number 8.